Toward the end of the last section, we looked at graphing two sides of an identity or of a possible identity to determine whether they were actual identities. And that's what we're going to be focusing on in this section, but not using a calculator, but by using all of the different identities that we have. So just a quick review, we have the reciprocal identities, and when you write your note card out to use to study from, make sure you write the name reciprocal identities, because sometimes you have to be able to refer to that. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. The Pythagorean identities we're going to use all the time. And remember, this isn't just good for sine squared plus cosine squared equals 1. I can use this and solve for sine squared is equal to 1 minus cosine squared equals 1 minus sine squared, etc. And then of course our even odd identities. So be sure to have these on a note card or a page, because they're going to be very happy and handy when you're working through your homework for this section. Now to get started, let's go ahead and look at some identities, using identities to simplify an expression. So for this one, we're not trying to establish an identity, we're going to use identities to simplify. And again, we want to be able to refer to all of the identities on the first page, so it's nice to have those on a note card. Okay, so to get started here, our first identity that we want to simplify, or our first expression I should say that we want to simplify, is cosine of x plus sine squared of x over cosine of x. So if we want to use some identities to simplify this, the first thing that we could do is start with a more complicated piece or find a common denominator. And it looks like for this one, finding a common denominator would probably be best. So I can rewrite this one as cosine of x over 1 plus sine squared of x over cosine of x. Now the common denominator here would be cosine of x, so I'm going to go ahead and multiply top and bottom of the left-hand side by cosine of x. And then when we simplify, I'd have cosine times cosine is cosine squared of x plus sine squared of x all over cosine of x. So I can rewrite that as a single fraction, or I can keep it split into two, it doesn't matter. Now recall the Pythagorean identity that said sine squared plus cosine squared is 1, so sine squared of x plus cosine squared of x equals 1. So what I can do is I can take this and replace this entire expression with 1. So this would mean I would have 1 over cosine of x. 1 over cosine of x is the reciprocal identity of secant of x. And so that's how this one simplifies, is down to secant of x. So it's a lot easier to work with the secant of x than to work with that original expression that they provided. And it's, like I said, it's good to be able to identify that we're using the Pythagorean identity, and you have to show your work. You have to explain what you're doing. You have to include all the identities that you're using at a certain point. Now this one, 1 over cosine of x, was a reciprocal identity, so we could include that idea as well in that name. So this is a reciprocal identity. Okay, let's do another one. Let's do cotangent of x times tangent of x minus secant of x. Now again, my math lab does not put parentheses consistently around the arguments of your trig functions, but that's something I'll be looking for when I'm grading, because it clarifies what the argument is, because some of these can be a little bit ambiguous. Now this one, as we're simplifying, one strategy that we can use is we can take everything in the expression and convert it to sine and cosine. So that way we're all kind of working on the same thing. So cotangent would convert to cosine of x over sine of x. Tangent is sine of x over cosine of x. And then secant is 1 over cosine of x. So I have everything converted across. I haven't really done anything yet. I haven't canceled anything. But for now, I have everything converted across. Next thing I think I'll do is I'll rewrite this as a common denominator, a single denominator in my brackets. So that would be sine of x minus 1 over cosine of x. Now again, you need to put parentheses around the arguments of your trig function. For instance, does sine of x minus 1 or sine of x minus 1 or sine x minus 1? I'm not sure without the parentheses, but with the parentheses it's really clear that it's this one. So make sure you simplify those and put parentheses around the arguments of your trig functions all the time. So here the cosines canceled, and when I simplify this I'm left with sine of x minus 1 all over sine of x. Now it doesn't tell me how far to go with simplification, but usually we want to break it down as far as we can. Now for this one I can split this up into two separate fractions, sine of x over sine of x minus 1 over sine of x, and of course anything divided by itself here is 1, and 1 minus sine of x is equal to cosecant of x. So there's my simplification. Okay, so again, always put parentheses around the arguments of your trig functions, and then also be sure when you're working that you're always justifying the steps. So here, let's start with another one, 1 over secant squared, and let's do theta this time, plus 1 over cosecant squared of theta. Well, let's use our reciprocal identities. So 1 over secant squared, this would be cosine squared. And then 1 over cosecant squared would be sine squared. So when I moved from this top line down here, I basically applied my reciprocal identities. And again, you should be able to state what you did to move from one step to the next. And then from this step down, sine squared plus cosine squared, or cosine squared plus sine squared, this is equal to 1. So this simplifies because this is my Pythagorean identity. So again, once you start with simplification, make sure that when you write in your steps, you justify each step and show what's happening on each step. So again, simplification. Now for simplification, sometimes you'll be finding a common denominator. Sometimes you'll be adding or subtracting after you find that common denominator. And even you could be simplifying by using some algebraic skills. So let's look at an example. 3 cosine squared of w plus 16 cosine of w plus 21. So our instructions here are to factor. Well, it doesn't look like it's real obvious how to factor this. So what I'm going to do is I'm going to make a substitution. I'm going to let x equal cosine of w. So this will look like 3x squared plus 16x plus 21. Now I think this is a lot easier to factor without all the cosines and the w's in. So this would factor into 3x and x, and then you can either use reverse FOIL or the AC method, however you best know how to FOIL, or reverse FOIL or factor in this case. 21 is prime, 3 is prime, so I know it has to be 3x and x if it's going to factor. 21 has to be 3 and 7, so it either has to be 3 here and a 7 here, or a 7 and a 3. I need to add up to 16 for my outside and inside terms, so that'll go 3 and 7 with both adding. So again, it's a trial and error process there. Now once I get it factored, let's check it. 3x squared, 9x plus 7x is 16x, 7 times 3 is 21. Now we know x is cosine of w, so this is going to be 3 cosine of w plus 7 times cosine of w plus 3. And that's the correct factorization. Now sometimes we'll be factoring because once I factor, then I can usually simplify further. So that might be a preliminary step in factoring. Let's look at another one. Let's look at tangent beta over cotangent of beta. And again, our rules here are to simplify. So to get started, let's write out what this means. This means to take tangent beta over 1 and divide it by cotangent of beta over 1. Now remember, when you divide by a fraction, you multiply by a reciprocal. So this is tangent beta over 1 times 1 over cotangent of beta. So again, when you divide by a fraction, you multiply by the reciprocal. Tangent beta over 1. And then here I have this 1 over cotangent beta. Well, remember, 1 over cotangent beta is the same as tangent beta. And I can write that over 1. So remember, what we have here then if we look back at all of the different identities that we have, 1 over cotangent was equal to tangent. So this is my reciprocal. So from here, I'm going to write in that that was my reciprocal identity. So this is my reciprocal identity. And then tangent times tangent is tangent squared. So this is tangent squared beta for my simplification. So again, as you're going through here and simplifying, a lot of these are pretty straightforward in terms of seeing what to do, but some of them you have to make a couple tries at. They're not going to always be so obvious. So let's get into a couple other ones, not just simplifying, but let's get into establishing an identity. Now, establishing an identity, there's a few tricks to this one. So let's first of all look at a problem so we can see how it's different than just simplifying. So for simplifying, we were just given an expression. We're asked to add, subtract, multiply, divide, that type of thing. But when we establish an identity, and again, these are similar to the calculator problems we did when we graphed both sides, and if it was the same line, then we knew it was an identity. When we establish an identity, there's a few things that we want to look at. There's a few strategies that we should consider. First of all, you have to know all of your fundamental identities, and you need to know their equivalent forms. So for instance, sine squared plus cosine squared is 1. That also tells me that sine squared is equal to 1 minus cosine squared. So you need to know all their different forms. Also, we usually start with the more complicated side. Now, sometimes this is obvious which is more complicated, but sometimes it's not. So again, you have to be careful here. This is just a suggestion. Sometimes it works well, sometimes it doesn't. There's more than one way to establish an identity. So if you're working with somebody else, they might say, well, wait a minute, I want to start with this side. That's fine. We should still be able to get to the same solution. However, sometimes it's a little easier to start with one side than the other. So try and start with the more complicated side. It won't always work, but it's usually a good first step. Okay, next, a lot of times it's nice to take all of the trigonometric functions and rewrite them in terms of sine and cosine. Now, this isn't always going to work with all problems, but it should work with quite a few. Might have some algebra, we might have some factoring that we have to do, we might have a common denominator that I need to find, we might need to multiply by the reciprocal. When we're dividing, we might need to multiply by the conjugate. So the conjugate of a plus b is a minus b. So we might have to multiply by the conjugate. We might have to rewrite things in terms of our Pythagorean identities in a different form. So keep that in mind as well. Keep in mind when we're doing this, we're trying to work toward the side that's not changing. So keep in mind the side that is not changing. That's our goal, and because it's our goal, we should always be looking at what we're working with and seeing if it's getting closer and closer to that. So you can see that where we have a lot of different strategies here. There's not always going to be one strategy that will work for everything, but this is kind of a good place to start. So we're going to look at quite a few of these problems. Now in my math lab, because they can't just look at you, show your work step by step, they usually have you choose from several different options in terms of what would be the best way to work this problem. On the test, on the exam, it's going to be handwritten. You will not have like the choices like A through D to choose from. You're going to have to write these out. So that's how I'm going to be working these problems as well, as I'm going to just be writing them out by hand, justifying all of my steps, just like I would expect to see on the exam. Okay, so let's go ahead and look at an example of what you might come across in my math lab. So this is the problem that you might see in my math lab. Now usually on a test, you would just be given this piece right here, and then asked to work through and establish the identity however you want. You wouldn't have these A through D options to look at. You could just go ahead and kind of freelance your work, because there is more than one way to approach this. Now my math lab is saying, which of the following shows the key steps in establishing the identity? Well, remember our rules or our suggestions start with the more complicated side. Well, they're telling us which side to start with. So they're saying on all of these, A through D, to start with the left-hand side. So they're giving you a hint on how to start. So let's go ahead and start with the left-hand side. And the left side in this case is definitely more complicated. So that would be cosecant squared of theta 1 minus cosine squared of theta equals 1. So we're starting with the left side and we're trying to make it look like the right side. Okay? So it looks like a couple things going on here. On our options A through D, it looks like I have several different next steps that I could look at. I think the way I would like to work this problem is I would like to go ahead, I could think about rewriting this in terms of sine and cosine, but if you notice here on my second options for all of these problems, it looks like to me that they are rewritten partially in terms of sine and cosine, but not this cosecant squared is always there. So I don't want to do that all the way. So let's go ahead and look and see what would happen if maybe we would distribute the cosecant squared. So if I distributed that cosecant squared, and that would go to both terms in the binomial, that would look like cosecant squared of theta times 1 minus cosecant squared of theta cosine squared of theta. So that kind of follows along, I think, with cosecant squared. Yeah, this is kind of looking like C right now. So if I distribute, this definitely wouldn't be a secant and a sine, so I can get rid of this option. It definitely would have a subtraction here, so I don't have this as multiplication, and I don't see where the sign would come in. So I'm thinking that C is going to be my best bet, but I have to make sure I keep continuing on to make sure that this this identity establishes just like we'd expect to see. So far we have everything that matches. Now remember, cosecant squared is in our final step here before we get to 1. So let's go ahead and see if we can rewrite this a little bit. So we have cosecant squared of theta minus cosecant squared and cosine squared. Well, cosecant squared is 1 over sine squared, and then I just multiply by cosine squared. So what I did here is I used a reciprocal identity. And again, you need to always establish why that's a true statement that you just rewrote. And then I can combine cosine squared over sine squared into cotangent squared. Okay, and so that's still following right along here. And now somehow I have to get this to a 1. Well, let's recall our Pythagorean identities. So the one that I'm thinking of is 1 plus cotangent squared of theta equals cosecant squared of theta. Now this doesn't quite match that, but you can tell it's pretty close. If I could move this cotangent squared over, I would end up with 1 equals cosecant squared of theta minus cotangent squared of theta. And so again, it's important to always show what you're doing here. This would equal 1 because of this Pythagorean identity. So this has been established. So this is equal to a 1, which is what I wanted this right-hand side to turn into. So the identity has been established. Now again, my math lab gives you a bit of a start on this. It kind of gives you an idea of where to go, and you have to pick through the steps to see which one works. But on the exam, you will just be given the original identity, and you can choose how to work it. You don't have to follow the prescribed method that my math lab is doing. You could create a different way to solve this problem. For instance, you might be able to rewrite this in terms of sine and cosine right off the bat and get started from there to establish this identity. So again, there's more than one way to do these. Just make sure when you do these, you always show your work and you always justify all of your steps. So instead of pulling more from my math lab that have the steps that you have to follow, let's go ahead and look at some where we can kind of decide how we want to do that. You know how the process works in my math lab, but we can also just kind of experiment with these, see what the more complicated side is, and see if we can establish our identities without that guide that's provided by my math lab. So this one, let's do 1 minus sine x over 1 plus sine x minus 1 plus sine x over 1 minus sine x. And what we want to do is we want to establish this identity to see or to show that this equals negative 4 tangent x secant x. Okay, so remember our rule, start with the more complicated side. So I would like to start with the left-hand side because it definitely looks more complicated to me. I think I need to find a common denominator. So our common denominator would be 1 plus sine x, 1 minus sine x. So on the right hand side I'd be multiplying top and bottom by 1 plus sine x. And I need to make sure I have parentheses everywhere because if I don't, those technically don't distribute through the binomial. Okay, so for our numerator over here on the left I would have 1 minus sine x times 1 minus sine x. Okay, and then over here on the right hand side I'd have minus 1 plus sine x 1 plus sine x. Okay, and the denominator is that conjugate 1 plus sine x, 1 minus sine x. And then what I could do is I could FOIL each of these. First, outside, insides, and lasts. It's going to have been a while since we FOILed. So first would be 1. Outside and inside would each be a minus sine x. Minus sine x is a minus 2 sine of x. And my last terms would be a plus sine squared of x. Minus. Now this minus sign needs to distribute through, so I'm going to go ahead and put up a big set of brackets or curly braces. This would be 1 plus 2 sine of x plus sine squared of x. And this is all over. Multiply here and I'd have 1 plus sine x minus sine x cancels, 1 minus sine squared of x. Now maybe I should have left that factored into 1 plus sine, 1 minus sine, I don't know. I just went ahead and multiplied it and hopefully it'll work out. My next step will be to distribute the negative. So 1 minus 2 sine of x plus sine squared of x minus 1 minus 2 sine of x minus sine squared of x. So again, that's taking this minus sign and distributing through. This is all over 1 minus sine squared of x. Okay, so I think some things will cancel here. The 1 and the negative 1, the sine squared and the negative sine squared, and it looks like I will be left with negative 2. Whoops, there's 2 of those, so it'd be negative 4 sine of x. And then 1 minus sine squared of x, that's equal to cosine squared of x from sine squared plus cosine squared equals 1. And if I subtract sine squared from each side, and again you need to justify this, so that means I can rewrite that as cosine squared of x. Now remember, we have to keep our eye on what we're trying to do here. We need a negative 4, which is, I have that, tangent secant. So let's rewrite this in terms of tangent. That would be sine x over cosine of x. And then I'm left with 1 over cosine of x. Sine over cosine is tangent. and 1 over cosine is secant. So in terms of the identities that were used here and the way that we have to justify this, sine over cosine equaling tangent is our quotient identity. So again, this is our quotient identity. And you need to be able to state these and to justify the steps. And then 1 over cosine equaling secant would be our reciprocal identity. Okay, so we've established the identity. So these can be pretty long problems. The important thing here is you always show your work. You never skip any steps, you never assume anything, and you always explain everything. Now, like I said, some of these are pretty long, and sometimes you'll start on one side and you'll realize it was a bad place to start. And so you can just kind of start over. Make sure you show all of your steps, so if you ever have to go back and find a mistake, it's easy to find when you have all of your steps shown and you haven't skipped anything. So for our next one, we're going to be using 1 minus sine theta excuse me, over 1 plus sine theta equals tangent theta minus secant theta quantity squared. So again, our rule is usually start with the more complicated side, rewrite in terms of sine and cosine. You know, there's quite a few different things that we can look at here. I think this is definitely the more complicated side, just because it's in terms of tangent and secant. So I'm going to start with that. And again, there's more than one way to do these, so you might have a different approach, and that's absolutely fine as long as you show your work. You have to be able to show each step and justify them. So quantity squared means I multiply it by itself twice. Okay, and then what I'll do here is I'll FOIL this out. So tangent times tangent is tangent squared of theta. Outsides would be negative secant tangent. Inside would be negative secant tangent. So this is minus 2 secant theta tangent theta. And then my last terms would be a negative secant theta times a negative secant theta would be a positive secant squared theta. So that's this right side. I'm starting with this right side, and I'm trying to make it look like this left side. Okay, so that would be one spot that we could start here. Then what I can do is I can rewrite in terms of sine and cosine. So tangent squared is sine squared theta over cosine squared theta. Secant is 1 over cosine of theta. Tangent would be sine over cosine. Secant squared is 1 over cosine. So what we have here then is we have this common denominator of cosine all the way across, so I can rewrite in my next step. So that would be sine squared of theta minus 2 sine of theta plus 1 all over cosine squared of theta. Now this sine theta minus 2 sine theta plus 1, it might not look familiar, but this is something similar to, let's say, x squared minus 2x plus 1. And that factors into x minus 1 times x minus 1. So that means that this numerator factors into sine theta minus 1 times sine theta minus 1. And again, your algebra skills are getting a huge workout here. You have to be able to remember to factor, recognize it in a little bit different form. Now this cosine squared theta, what is happening here is I should be able to rewrite this in terms of sine using a Pythagorean identity. So our Pythagorean identity that I want to use here is sine squared plus cosine squared equals 1. Well, if I solve this for cosine squared, I get 1 minus sine squared. Okay, so the numerator is sine theta minus 1 times sine theta minus 1, and then this denominator will be 1 minus sine squared theta. Now that's the difference of perfect squares, 1 minus sine squared. It may not look like it, but it's the difference of perfect squares like a squared minus b squared. So this will factor as well, this denominator will factor as well into 1 plus sine theta, 1 minus sine theta. Now a couple things to keep in mind. See how close these are to canceling? The only thing that's different here is a sign. So if I go ahead and pop a negative sign out from just right here, what that's going to do is it's going to flip my signs into negative sine theta plus 1. And then I can come down here and rewrite that as 1 minus sine theta. And then the sine theta minus 1 over here can just stay the same. So what ends up happening is this cancels, the 1 minus sine thetas cancel, and I'm left with a negative sign, sine theta minus 1 all over 1 plus sine theta. And then I can distribute the negative, so it's going to be a negative sine theta plus 1 over 1 plus sine theta, which is almost exactly what I want. I'm going to rewrite the top as 1 minus sine theta over 1 plus sine theta, and that is what I wanted on the other side, on 1 minus sine theta over 1 plus sine theta. So this has been established. So I think I showed my Pythagorean identity, I showed my factoring. I guess the only thing I didn't do was justify this step, and I should go back and do that. This secant squared is 1 over cosine squared. That would be a reciprocal identity. And secant 1 over cosine is reciprocal identity. Tangent is sine over cosine is my quotient identity. And this is your quotient identity as well. QI, quotient identity. So these are long, but they're kind of fun. They're interesting. A lot of times you'll have to back up maybe if you get to a spot where the problem that you were working on didn't quite work out and you needed to try a different approach. These take a long time. I'm going to try and do one more so the video doesn't get too long. So let's go ahead and have a look at a pretty complicated one, so that way if you come across it in your homework you'll have a framework to work off of. So for this one, let's go ahead and look at a cotangent alpha over sine of alpha plus 1. Now alpha is only in the argument of the trig function. The plus 1 is outside of that. And like I've said many times, is please make sure you put parentheses around the arguments of your trig functions just to clarify that. It'll help remove any potential errors there. Now for this problem, we need to make sure that we decide which is the more complicated side. And if we look at this, I think the side with the fractions, they both have tangents and secants and stuff like that. One has cotangent, but the fractions I think are a little bit more difficult. So I'm going to start with this side. And again, there's more than one way to do these. So if you have a different approach you'd rather follow, that's great. And I think what we should do is find a common denominator. So I'm going to have cotangent of alpha times, actually let's change that up a little bit. I'm going to have cotangent of alpha times sine of alpha minus 1 over sine of alpha plus 1 times sine of alpha minus 1. So that's the left-hand fraction, that's that common denominator, minus, okay, then I'll have cosine of alpha, and then here I'll have sine of alpha minus 1, and then I'll multiply top and bottom by sine of alpha plus 1. Okay, so the green is multiplying top and bottom to get that common denominator. Okay, so once I have that common denominator, what I can do next is I can take this cotangent alpha and I could distribute that if I wanted to, or I could rewrite it in terms of sine and cosine. Have a couple different options there, but like I said before, there's more than one way to work these problems. So cotangent of alpha would be cosine of alpha over sine of alpha, and then I have sine of alpha minus 1, and I'm going to go ahead and write this as a single fraction. Oh, actually I'll split it up into two fractions. okay, minus cosine of alpha times sine of alpha plus 1. Now this is all under or over sine alpha plus 1, sine alpha minus 1. Now this is the difference of perfect squares. These are conjugates. So the difference of perfect squares factors into conjugate pairs. These are those conjugate pairs. So the next thing I want to do is I want to take this cosine over sine and distribute it through, and then the same with the cosine of alpha. So here I will end up with cosine of alpha over sine of alpha times sine of alpha over 1 minus, I'm going to distribute it through to the negative 1 now, so there's my minus sign, cosine of alpha over sine of alpha. Okay, so that's my first fraction. My second fraction then would be minus cosine of alpha sine of alpha minus cosine of alpha, and that's over 1. So again, I took the cosine of alpha and I distributed it to the sine of alpha and to the plus 1, so a negative times a positive is that negative value. So I should clarify that a little bit. So this minus, I kind of have it written strangely, so let's clarify this a little bit. I could change this to a positive, and then this would be a negative, and the negative already distributed to here. So I think this kind of makes that a little bit easier to understand what's happening there. And then of course in the denominator, I have that sine alpha minus 1, sine alpha plus 1. If you multiply that out, FOIL it out, first outside, inside's last, I'd get sine squared alpha minus 1. Now I see a Pythagorean identity coming up here pretty soon. Sine squared alpha minus 1 should be cosine squared of alpha. Okay, so from here I see some things canceling. The sine alphas cancel. And then I can rewrite this. Cosine over sine would be my quotient identity. I've already used that up here when I took cosine or cotangent and rewrote it, so this is my quotient identity. So when I do that and I rewrite, I end up with cosine of alpha minus cosine over sine is cotangent of alpha, okay, minus cosine of alpha sine of alpha, and then we have this minus cosine of alpha as well. Now this denominator, the sine alpha, is gone, and here it's rewritten in terms of cotangent, and then the denominator, I want to rewrite this as cosine squared of alpha. And this comes from my Pythagorean identity. And this was sine squared plus cosine squared equals 1. So if I took sine squared minus 1, I would get cosine squared. Okay, so lots of algebra there. Now I see here that cosine alpha and a negative cosine alpha, they cancel, they sum to 0. So I'm left with negative cotangent alpha, negative or minus cosine alpha sine alpha, and it's all over this cosine squared alpha. My next step will be to split this up into two steps, negative cotangent alpha over cosine squared of alpha minus cosine of alpha sine of alpha over cosine squared of alpha. Okay, now cotangent I should be able to rewrite, and when I rewrite this, wait, I think I have a mistake up here. Sine squared minus 1, sine squared of alpha minus 1 would equal negative cosine squared. The reason that would be is if I subtract the 1 over, I'd have sine squared minus 1 plus cosine squared equals 0, then I'd have to subtract the cosine squared over. So make sure we get that put in there. So there's a minus on each of these. So when I rewrite this, I have a negative divided by negative is a positive. So I have cotangent, which is cosine of alpha over sine of alpha, times 1 over cosine squared of alpha, and that's all from right here, minus cosine of alpha, sine of alpha over cosine squared of alpha. So hopefully we'll get some things to cancel here. One of these will cancel one of these, leaving a cosine. One of these will cancel with one of these, leaving a cosine as well. And let's see what we have left. I have 1 over, actually let's leave these as two fractions, 1 over sine alpha times 1 over cosine of alpha minus 1 over cosine, actually sine over cosine. So 1 over sine of alpha is going to be secant. 1 over cosine is going to be cosecant. So this is secant alpha cosecant alpha minus tangent alpha. Now if I wanted to, I could have left this sine cosine form, but usually the instructions are to not leave any fractions. And if we go back, this is what we wanted to get to anyway. This was the right-hand side of the equation. So this is an identity and it has been established. There's more than one way to do this. Just make sure that however you do it, you explain each of your steps. And don't drop any negatives like I did up here. Be really careful, because if you mess one of these up, you've wasted about 15 minutes of your life. So work slowly, work carefully, and as usual, if you have any questions, please let me know.